Hello guys, this is for our class for Monday, February 22nd, and also my Tuesday class, the 23rd. These are the two lessons, 1.R.4 and 1.4a. So we are going to be simplifying radicals today. So we're going to simplify algebraic expressions that contain square roots. We're going to simplify square roots that contain variables, and we're going to simplify radical expressions that contain cube roots. So we're going to be able to divide up anything under a radical. So a radical is this sign right here. Anything under the radical sign is called a radicand. So if you have the radical of a times b, you can separate it, like this example here. And also, if it looks like the whole, we have a radical and then a fraction underneath it, we're going to divide up that fraction and have a radical divided by a radical. So we'll be doing both of those things. So I went ahead and listed the first 15 perfect squares. Now, why are these perfect squares? Because 1 squared is 1, 2 squared, which means 2 times 2 is 4. So 4 is the second perfect square. 3 squared is 9. Oh, that shouldn't be a 3. That should be a 9. Sorry. Yeah, that should not. 3 is not a perfect square, but 9 is. 4 squared is 16, all the way to the 15th perfect square. So if you memorize these numbers, the next problems that we do are going to be a little bit easier for you because we're going to be looking for factors that are perfect squares. All right, so here we go. So I'm going to show you 3 different ways to do this problem. The first way is to find a calculator that will do it for you. Last week I talked briefly about the TI-30XS calculator. I know some of you are using a computer calculator, which is totally fine. Some calculators will simplify radicals for you and some will not. They put them directly into decimals. Now, when we get into cubed roots and roots bigger than 2, this calculator won't do it for you. So you have to know how to do it anyway. But the calculator that I just showed you will simplify square roots. Now, if you don't see a number here, it's always a 2. So in other words, if we want to know what the square root of 25 is, we're looking for a number times itself that equals 25. And of course, 5 squared is 25. So the square root of 25 is 5. Now, 48, there is not a number times itself that equals 48. That's why it tells us to simplify it. It's a non-perfect square. So first way, I would suggest you put it in your calculator and see what your calculator says. The second step is we're going to look for the biggest factor of 48. That is a perfect square. So on that previous page, what's the biggest number listed that is a factor of 48? Well, the answer is 16, because 16 times 3 is 48. 16 is a perfect square. The square root of 16 is 4. 3 is not a perfect square, nor does it have factors that are perfect squares. So that stays under the radical, and the final answer is 4 square roots of 3. Now, another way to look at it, and what we'll do when we get into roots that are bigger than 2, is we're going to list all of the prime factors of 48. All right, so for example, I know I can divide 48 by 2, which is a prime number. So I'm going to circle my prime number. So 2 times 24 is 48. I know 24 is divisible by 2. So 2 times 12 is 24. I know 12 is divisible by 2. 2 times 6 is 12, and I know that 6 has 2 prime factors, 2 and 3. So I have 1, 2, 3, 4 2s. I have 1, 2, 3, 4 2s, and I have the number 3. So since this is a little 2 out here, this is telling us how big our groups get to be. So you know when you go into a shoe store and you're looking at you're wanting to buy shoes, you're not going to grab a box without knowing what's in it, right? So for them to show you what the shoe looks like, they're going to take one of the shoes and pull it out of the box so you can see what it looks like. But when you get to the cash register, of course, you're going to buy a pair of shoes. So for the one sitting outside the box, it represents 2 that's inside the box. Well, this little 2 right here tells us that we are going to get to circle pairs of numbers. And for every pair that we circle, we get to pull out 1 to see what it looks like, right? So there's a pair of 2s. I get to pull 1 out. It represents 2 on the inside. So 1, 2 right there represents those 2s, those pair. And then this little 3 is by itself. It doesn't have a pair. So it stays under the radical. So since I circled 2 groups of 2, I'm going to multiply 2 times 2. I get 4, and 3 stands alone. So once again, I got 4 square roots of 3. All right. So both of those are ways you can think about simplifying the square root of 48. All right, so let's look at the square root of 63. So the first way I'm going to think is I want the factors of 63. What's the biggest factor of 63 that's a perfect square? Well, I do know that 9 times 7 is 63. I know that 9 is a perfect square. The square root of 9 is 3. And 7 is a prime number with no perfect squares as factors. So the answer is 3 square roots of 7. Now, if I did it the other way, if I thought of the factors of 63, I could have started with 3. I know that 3 times 21 is 63, and 3 is prime. And then 21 I can break down into 3 and 7. Those are both prime numbers. So 63 is 3 times 7. Once again, I get to circle a pair. So for every 2 numbers I circle, I get to bring 1 out of the box. And then 7 is in the box by himself, so he has to stay in there. So both ways, I got the same answer. All right. Ooh, let me erase all this stuff. All right, so like at the introductory slide, I showed you that we can take this fraction and we can turn it basically into a radical divided by a radical. Now, hopefully you realize, since you memorized the first 15 perfect squares, that 16 is a perfect square. And the square root of 16 is 4. And then 75, we're going to think, what is the biggest factor of 75 that's a perfect square? Well, 25 times 3 is 75, and the square root of 25 is 5, and 3 stays under the radical by itself, and that is our final answer. All right, now we're going to throw in some variables, let's just look at a few of those problems. Now, so the first thing I have to tell you is when that number on the outside matches the one on the inside, those are a little tricky. First of all, 25 is a perfect square, and so is x squared, because 25 is 5 times 5, right? And x squared is x times x. Well, remember, we get to circle a pair and bring out 1. So I get to bring out this 1. And then I get to circle a pair of x's and bring out 1. However, and this is just a thing you have to remember, just write it down. When this number and this number on a variable matches, and they're the same number and they're even, you have to put that variable in absolute value marks. Because literally you cannot find the absolute value of a negative number. If you did have an absolute value of a negative number, it would not be a real number. And so that's a whole different type of problem we'll get into on Thursday. But anyway, so since these are both perfect squares, There's no radical in our answer. However, since these two numbers match and they're even, I have to put this x in absolute value marks. And you're just going to have to remember to do that. All right. So look at the second one. 144 is a perfect square. It's 12. So the square root of 144 is 12. The square root of y squared is y. But since this number and this number matches and it's even, we have to put that variable in absolute value marks. So this is the answer, 12, absolute value of y. That's only when they're variables and only when those two numbers match exactly under the radical and they're even. If they're odd, it doesn't even matter. All right, let's look at this one. Once again, we have a perfect square. The square root of 169 is 13. X squared is a perfect square because x times x is x squared, but it's reminding us that whatever x is, so let's say x is 3. Well, we agree that 3 times 3 is 9, and the absolute value of 9 is 3, right? But what if x equaled -3? Well, -3 times -3 is still 9, but the absolute value of 9, I'm sorry, the square root of 9 is not what we started with, it's the absolute value of this number. The absolute value of -3 is +3. I know, it's one of those weird exceptions. So just write this down. If this is a 2 and this is a 2, and it's a variable, you have to put that variable in absolute value marks or Hawks will count it wrong, okay? Now this problem, when we look at our original problem, this is a little 2 that we don't see, but these are not 2s. So when you go to write the final answer, you don't have to have any absolute value signs because those numbers don't match, okay? So let me talk about just this one problem real quick. Let me get rid of all of this notation. I wish I just had. So we're just going to use this area right here to talk about this one. All right, so we're going to break this down into 3, and then we're going to write out 10 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to write out 6 y's, right? 1, 2, 3, 4, 5, 6. Now, this is a little 2 that we don't see. If you don't see it, it's a 2 automatically. All right, we get to circle groups of 2. Well, 3 is alone, right? So 3 stays in by itself. Now look though, how many groups of 2 do we get to circle? 1, 2, 3, 4, 5 groups of 2, 5 pairs of x's. That's why the square root of x10 is x to the 5th. 5 x's outside the box represents 10 inside the box. Look at all of our y's. How many pairs do we get to circle? 1, 2, 3 pairs. That means we get to pull out 3 y's. So that's why y to the 3rd outside the radical represents 6 on the inside of the radical. And there aren't any left, correct? There aren't any left. The only thing left under the radical is the square root of 3. And that's why this is the answer. Okay, I hope that makes sense. So let's look at this one now. We have 16 is a perfect square. Y squared is a perfect square, but once again, these 2's match. This is a variable and 2 is even. So the square root of 16 is 4. The square root of y is y. The square root of y squared is y. But since those 2's match, we have to use the absolute value signs. That's a long, those are just long white, long straight signs, okay? So 4, absolute value of y. So next one, 72a squared. Once again, we have a variable that's squared. it matches this number. They're both even. So I have to use absolute value signs. So isn't 72, let's see. Well, I know that 72, I know 9 is a factor of 72, but it's not the biggest factor of 72. That's a perfect square. I believe, let's see what it would be. So 9, and then we have 16, and then 25, and then 36. Now, what if I used 9? Let's say I said, okay, well, I know the the square root of 9 times the square root of 8 is 72. And let's say I do 3 square roots of 8. Well, the reason Hawks would count this wrong is because 8 has a factor that is a perfect square. 2 times 4 is 8, and 4 is a perfect square. You understand? So that's why having that list in front of you is so important, so you can pick out the biggest number that is a factor of 72. So 72 is 36 times 2. And a squared is a times a, right? So square root of 36 is 6. Square root of a squared is a, but since these two numbers match and they're even, I must put the a in absolute value signs. And the only thing left under the radical is 2. So this is the answer according to Hawks and my open math. All right, let's look at letter C. So 12 is 2 times 6, okay, but 4 is a perfect square. So we're going to do 4 times 3 is 12, then x, y, y. All right, that little 2 tells me I get to pull out a pair. So this is basically 2 times 2, right? So the square root of 4 is 2. I get to pull out both of those x's. Pull it out, but once again, these numbers match, they're even. I have to put that in absolute value marks. The y also, I get to pull out one pair. So actually, you know what? I would write it xy together like that. And then what's in the radical by itself? Square root of 3. And that is the final answer. Okay? All right. Let's do 81. So 81 is a perfect square, and x to the 4th is a perfect square. Now this time they're both even, but they don't match. So we don't have to worry about the absolute value signs, okay? So this is 81 is 9 times 9. And then we have 4 x's. So we get to pull out 1 9. And then we get to pull out 2 x's, x squared. And that's the final answer. We don't need absolute value marks because these do not match. 64 is a perfect square. Now, let's go ahead and draw this out though. So 64 is 8 times 8. And then we have 1, 2, 3, 4, 5 x's and 1 y. So we get to pull out 1 pair of 8s. We get to pull out 1 pair, 2 pairs of x's, so x squared, and then these two are both inside by themselves, x, y. And that's the final answer. Oh, let me erase all this stuff. Hopefully you got that. All right, 18 is 9 times 2, and 9's a perfect square, right? And then we have 1, 2, 3, 4 A's, 1, 2, 3, 4, 5, 6 B's. So square root of 9 is 3. We have 1, 2 pairs of 8, and none of these exponents match, so we're good. We don't have to do any absolute value. So we get to pull out 2 groups of A's. Those are gone. And then for our B's, 1, 2, 3 groups of B's. 3 groups of B's. And is there anything left under the radical? A 2. And that is the final answer. All right, this one, we get to divide that up. So we're going to do 9, which is 3 times 3, and 13 A's, you guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 over 1, 2, 3, 4. None of our variables is a 2, so we're fine with that. So square root of 9 is 3. We get to circle 1, 2, 3, 4, 5, 6. So doesn't 2 times 6 equal 12? And there's 1 left over. So 6, that represents 12. And there's 1A left on the inside. And then the bottom, this is a perfect square. Square root of b to the 4th is b squared. We get to pull all those out of the radical. And that is the answer. All right, you also will have cube roots, okay? So since we did the first 15 perfect squares, you need to be familiar with maybe 5 or 6 perfect cubes. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. And finally, 6 cubed is 216. These get big fast, right? So as long as you're familiar with those first 6, then you're going to be good. All right, so now your calculator, or at least my calculator, won't do cubed roots unless it's a perfect cube. And 54 is not a perfect cube. So let's go back 1 second. 8, 27, 64. Those are perfect cubes. So look at this problem. 8 is a perfect cube, right? 54 is not a perfect cube. So we're going to do this like we did earlier, where we're going to turn 54 into those prime factorizations, or we could say, okay, what's the biggest perfect cube? So if we go back to this page, what is the biggest number on this page that's a factor of 54? Well, hopefully you know it's 27, right? So 54 divided by 27, let's see, 54 divided by 27 is 2. So 54 is basically 27 times 2. 27 is a perfect cube. And then we have 6 x's. 1, 2, 3, 4, 5, 6. Okay, so 27 is basically 3 times 3 times 3. So if I wrote out 3 times 3 times 3, I get to circle a group. This tells you how big your groups have to be. 3 times 3 times 3, I would have a group of 3 3s. In other words, the cube root of 27 is 3. That's a perfect cube. And then I get to circle groups of 3 x's. I get 1 group, 2 groups. So x to the first, x to the second. So x to the second in this situation represents 6 x's, right? 2 groups. So then what's left over? A 2. But here's the kicker, guys. If you and HOTS do not remember to put that tiny little 3 in that radical, which I cannot for the life of me remember, it will count it wrong every time. So if you put this in HOTS, but you don't put that little 3 in there, it will count it wrong. I've done that 100 times. All right, now 8 is a perfect cube. So basically 8 is 2 times 2 times 2. So there's our group of 2s, one group of 2s. But then let's do our variables. We have 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 z's. Oh my goodness. So first of all, we know that 8 is a perfect cube. So we get a 2. Then we get one group of x's. One group of x's that represents 3. And then how many groups of z's? 1, 2, 3 groups of z's. So z to the third. So 3 times 3, that represents 9 z's, right? And there's 2 left over. There's 1 z left over. There's 1 x left over and 2 z's. So we're going to do our radical with our little 3 in there. So we marked out those. So what's left on the inside? X and then z squared. There's 2 of them. So that is your final answer. And none of our variables, exponents, have matched what's on the outside, so we haven't worried about any of that. And even if they do match and they're odd, you don't have to do any of the absolute value signs. All right, I hope everybody's still with me, okay? All right, 1.4, we're doing the properties of radicals. And we've kind of talked about that quite a bit anyway as we've gone along. These kind of go together. But anyway, what we want to do is determine what are real numbers and what are imaginary numbers. So that's Wednesday and Thursday's lesson, imaginary numbers, but we just want to see what's a real number. So do you agree with me that any number times itself is going to give me a positive number, right? So 3 times 3 is 9. Is there any way we would ever get a negative square root? Is there a number times itself that's 36? No, because even if we squared -6, we still get a positive number. So if you have a square root, or even a 4th root, or even a 6th root of a negative number, that's impossible. You can't. It's not real. Because every time you multiply 2 negative numbers, you get a positive. So basically, if this is even, you cannot get a negative number. However, what if this is an odd number? Well, don't you agree with me that -3 times -3 times -3 is -27? That's true. So the square root, or excuse me, the cubed root of -27 is a real number, and the answer is -3, because -3 cubed is -27. So if this number right here is odd, this is a real number. If this number right here is even, and if they give you a negative inside the radical, that is not a real number. Now, if you put this right here, the square root of a 9/121, and write it like this, that's different. That's saying, what is the opposite of square root of 9/121, which is the square root of 9/121 is 3/11, and then the opposite of that is -3/11, which is a real number. But if the negative sign is under the radical, it's not real. So get rid of this. So this is a real number. These are both perfect squares. The square root of 9 is 3. The square root of 121 is 11. And that fraction is a real number. And since it's real, they want you to give the answer. This is also real. The cube root of -27 is -3, which is a real number. So both of those were good. So let's look at these examples. So remember, if you don't see a number, it's 2, right? So we could find the square root of 24, which is, you know, like, what would it be? 4 square roots of, no, it would be 2 square roots of 6. And then they want to know, what is the opposite of that? What is the opposite of 2 square roots of 6? It'd be the -2 square roots of 6. And that's a real number. That's fine. Now this one right here, we're okay, but then it wants to know the square root of a -24. Nope, that is not real, not a real number. Can you find the opposite of a cubed root? Yes. This would be, I don't know, I'd have to take the time to do this. I don't even think you can simplify 24, because 2 times 4 times 6. So that, yeah, that would be 8. So this would be basically 8 times 3. And the cubed root of 8 is 2 square roots of 3. And make sure you put that little 3 there. And then it wants to know what's the opposite of that. And that is the opposite. So this is a real number. This is not real. This is real. Can you have the cubed root of a negative number? Yes, you can. This is also -2 cubed roots of 3. These are the same. This is an even number. Can you have the even square root of a negative number? Impossible. Not real. This is an odd number. So can you have the odd root of a negative number? Yes. And can you find the opposite of that negative number? Yes. So this is a real number. So some of your HOTS questions will just be, you have to identify real and non-real answers. And if it is real, then you have to simplify it. So that's how you think about that section. All right, so this is a 2 and it matches this 2. So be careful on both of these because these match and they're even. 169 is a perfect square. Square root of 169 is 13. Square root of z squared is the absolute value of z. Same thing, perfect square, 7, absolute value of y, perfect square. All right, now this one, let's go ahead and list those factors of 32 because this is a 5. We don't know our 5th roots, who knows? All right, so what can I divide 32 by? I know I can divide 32 by 2 and I get 16. 16 is 2 times 8. Let's go ahead and circle our factors. 8 is 2 times 4, and then 4 is 2 times 2. So 32 is 1, 2, 3, 4, 5 twos. 1, 2, 3, 4, 5 twos. 1, 2, 3, 4, 5, 6 X's, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 Y's. Now, remember, this tells us how big our groups get to be. So we have one group of 5 twos. So we get to pull out one that represents these 5. Okay? So that's a perfect, whatever, 5th root. 1, 2, 3, 4, 5 X's right there. So I get to pull out one that represents 5. And there's one left over, right there. And then how many groups of Y's? I get 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. So I get 2 groups of Y's, 2 of them. And 2 times 5, that represents 10. And there's one Y left under the radical. So don't forget to put your little 5 in there. And what's left over? X, Y, X, Y. There we go. That's the final answer. All right, we have another one over here to the right. So 14 is 2 times 7. There's nothing we can do with that. There's 2 and 7 have no perfect squares that are factors. So guess what? 14 stays under the radical. Now, if we divide 14 by 2, right, we have 7 groups of Y's. Y to the 7th would outside the box would represent 14 on the inside. So then everything else gets left. 14 has no factors that are perfect squares, and Z is all by itself. So that's the final answer. All right, here's 243. So let's break 243 down. Now, if I add 2 plus 4, I get 6, 7, 8, 9. So I know this number is divisible by 3. So 243 divided by 3 is 81. So this is a prime number. 81, we're going to divide that by 3, which is 27. 27 is 3 times 9, and 9 is 3 times 3. So let's put 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's our group of threes. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we get a big group of threes. There's 5 of them. That's a perfect cube, fifth cube root, whatever. I don't know how to say that. 1, 2, 3, 4, 5 x's. There's a group of 5 x's. Bring out 1. There's 1 left. And then we get 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So z squared, that represents 10 z's, and there's 3 left over. So under the radical, don't forget your little 5, we only have 1 x left over and z to the 3rd. And that's what we get. Okie dokie. Hopefully that helps you. All right, so this is some of your college algebra homework I saw. So I just wanted to do some of these with you. So you guys had multiplication on college algebra. So you can multiply radicals. So you'd multiply what's outside the radicals and what's inside the radicals. Both of these are inside. So square root 3 times square root of 15 is square root 45. Now the biggest factor of 45, that's a perfect square, is 9. So this is square root 9 times square root 5. 9's a perfect square, so we get 3 square roots of 5, and that's the answer. So for B, you can multiply what's outside and multiply what's inside. So 4 times 5 is 20. 6 times 42. 42 times 6 is 252. And then in my calculator, I'm going to write the square root of 252 is 6 square roots of 7. So 6 square roots of 7 times 20 is, well, anyway, so 20 times 6 is 120 square roots of 7. And that would be the answer on that one. And if you put this whole thing in your calculator, I believe it would just give you that exact answer. 4 square roots of 6, and then arrow right to get out of the radical, times 5 square roots of 42 is, oh no, it turns it straight into a decimal, so it won't do this one. It won't multiply. So you have to know how to do this one. So multiply what's outside the radical, what's inside the radical, simplify what's inside the radical, and then don't forget to multiply those whole numbers together. All right, so when you multiply 2 radicals, well, let's just see what happens. All right, so we're gonna distribute this to both terms, okay? So 2 times 3 is 6. Radical 2 times radical 6 is radical 12. And then we're going to put minus, we're going to do 2 times negative 1. So 2 times negative 1 is minus 2. And then square root 2 times square root 10 is square root 20. So then we have to break these down, you guys. So 12 contains the perfect square root of 4 times 3, right? So the square root of 4 is 2 square roots of 3. And then don't forget to multiply those outside numbers. So 6 times 2 is 12 square roots of 3. And then 20 would be square root 4 times the square root of 5. Well, the square root of 4 is 2 square roots of 5. And then finally, you're bringing down this negative 2 times, this is a negative 2 times 2 would be negative 4 square roots of 5. Well, you know how you cannot add or subtract unlike terms? Well, if these radicals don't match, that means that these two numbers are unlike each other and you cannot do anything else to that. You're done. All right, now this one we have to FOIL. We have to do front 2, outside 2, inside 2, last 2. So we're going to do 4 square roots of 5 times square root of 15. So square root of 5 times the square root of 15 would be what? 45, I believe. Nope, 75. So this would be 4 square roots of 75. Now we're going to do the outside terms. 4 square roots of 5 times 1 is 4 square roots of 5. Inside terms, negative 3 times square root of 15 is negative 3 square roots of 15. And then negative 3, finally we're doing negative 3 times 1 is minus 3. Okay, so what can we break down? We can break down 75. 75 is 25 times 3. Square root of 25 is 5. Square roots of 3. Bring down your 4. This is 20 square roots of 3. Okay? And then this cannot be broken down. This 15, it cannot be broken down. It's just 3 times 5. Those are not perfect squares. So that means the rest of these terms are unlike terms. So the final answer is 20 square roots of 3 plus 4 square roots of 5 minus 3 square roots of 15 minus 3. They're all unlike terms. The radicals do not match. So there's nothing else we can do. That's your whole long answer. All right. Wow, that was a lot, you guys. So by the end of this week, this is Wednesday, Thursday's class. By the end of this week, these are the sections you should have already completed. Actually, this is tonight, right? And then Wednesday's class is 1.6. So before next Monday, the 1st, you should have not only these 3 sections, but all of these sections completely done. All right, you guys, I will see you for class. Have a great night. Oops. I can get my video turned off. See you guys later.